Hello, in this tutorial we are going to find out cut length of 4-legged stirrup. Okay, so let's see what is 4-legged stirrup before. Okay, it is made of 4-legged. The cross-sectional area of 4-legged stirrup is twice of cross-sectional area of 2-legged stirrup, and hence it can resist greater stress and the shear force. Okay, so here basically we have the example regarding the 4-legged and the 6-legged as well. Okay, so you can see here in this column, or it could be beam as well, we have 4-legged stirrup. 4-legged stirrup is nothing but we have 2 stirrups. Okay, so we have one stirrup, this is the external stirrup, and we have one another stirrup, that is internal stirrup. Okay, so legs are 1, 2, 3 and 4. Okay, now here in 6-leg stirrup it could be 8 as well. Okay, so this is just an example: 4 leg, 6 leg, 8 leg, 12 leg. Okay, so according to the column or the beam size, so 1, 2, 3, 4, 5, 6, it is nothing but we have 3 stirrups over here: the external, then the next internal, the next internal. Okay, so we have 3 stirrups over here. So this is basically the 6 leg. Now let's see the example regarding the 4 leg over here. Okay, let's suppose this is our column. Okay, and this is the external stirrup. Okay, it is going here in this direction. Okay, and then here in this direction. Now with this we have another stirrup that is holding the inside reinforcement. Okay, it is going here in this direction, then it is coming over here. So one is the external, and on the top of this external stirrup, okay, on the top I am talking about. Okay, so on the top of this external we have another stirrup that is inside this. Okay, that is just supporting the inside reinforcement over here, but between these 2 stirrups we do not have any kind of spacing. Okay, both of these are connected. Okay, so we have no any spacing. So this is external, this is internal. Okay, and both of these are making what? 4 leg. 1, 2, 3 and 4 leg. So this is how in real on side we can place the 4-leg stirrup. Okay, so hope you really understand the concept. 4 leg is nothing but we have two stirrups. Okay, and 6 leg is nothing but we have what? 3 stirrups. 8 leg is nothing but we have 4 stirrups. Okay, so let's see how we can find out cut length of this 4-leg stirrup. Okay, basically as I have already mentioned that this is nothing but we have 2 stirrups over here, and for external one it is not very much difficult to find out the cut length. Okay, because we have find out it already in rectangular stirrup. This is the main stirrup that we need to find out the cut length of this stirrup. Okay, so given data over here is we have the column as 450 mm by 300 mm. Okay, this and this, and a dia of dowel bar is 12 mm. The dia of dowel bar, these longitudinal bars we are using at 12 mm, and dia of stirrup, whether it is this stirrup or this one, it is 6 mm, and a concrete cover is 40 mm we are using over here, and bend is 14 dB. We are taking here 14 dB. Okay, so let's see how we can find out the cut length. We will find out only the cut length of this one, this stirrup. Okay, then it is easy for us to find out this one as well. Okay, main is this one. Okay, in order to find out cut length of this stirrup, what we need to do is we need to first find out center to center distance. Okay, center to center distance between the first and the last dowel bar. Okay, this center to center distance. Center to center distance, this is basically A. Okay, 450 minus we need to deduct concrete cover at this end and concrete cover at this end, minus we need to do what? We need to deduct dia of this external stirrup as well. Okay, so we have 2 sides, so 2 into dia of external stirrup, minus we need to do what? Half dia of this main bar or the longitudinal bar at one end and half dia at this end as well. Okay, it will make the full dia. So it will give us this value, this center to center from this position up till here. So when we will put the values over here, 450, 40 minus 40. Okay, so 450, this one, this A, minus 2 into concrete cover, so 40 into 40, minus 2 into dia of external stirrup, so 6 minus 6. Okay, minus we need to deduct what? Half dia at this end and half dia at this end. So half plus half will make full as 12 mm, so 12 this one. So this is total of 346 mm center to center distance. So this is how we can find out center to center distance. Whether it is 4 legs, 6 legs and 8 leg, process will be same. Now cut centers between each bar. Next of it, we need to find out center to center distance between each bar. Right from this position up till here, right from this position up till here. Okay. So in order to find out this one, what we need to do is we need to divide this center to center distance on the spacing. Okay. Right now we have 4 legs. So we have spacing. How many spacing we have? 1, 2 and 3. Okay, so this is how you can find out the spacing. It is 4 leg. In 6 leg, the same way you can find out the spacing. Okay, so 346 divided by spacing we have 3, so it is 115.33. so this is basically center to center distance between each bar. Okay, now next to it, in order to find out this cut length, okay, this cut length, we need to find out out to out distance as well. This is center to center, right from this position up till here, but we need to reach up till this position. Okay, and here up till this position. So in order to find out this one, what we need to do is we need to use this formula: center to center distance plus half dia at one end and half dia at another end. Okay, this distance, okay, this distance plus half dia at this end and half dia at this end. Okay, so it will give us the total value as 127.33. so this external length for this stirrup is 127.33. okay, and this is what we need over here. Now let's put the formula. Okay, let's put the values in the formula and find out the total length over here. Now formula to find out the cut length for the 4 legged, okay, basically we are finding for this one. Okay, and this is easy as we did in the rectangular stirrup. It is A into 2 plus B into 2 plus hook length minus bend directions. Okay, and what is A? A is basically out to out distance. We are taking A as this value right now. Okay, for 4 legs case, this value. Out to out distance plus 2 into dia of stirrup in order to find out the full length. Okay, right from this position. Okay, let's suppose we have out to out distance from these two dowel bars, plus we need to take out to out distance from the stirrups as well. Okay, so 2 into dia of stirrup. Okay, and where B is equal to B, okay, minus 2 into concrete cover. Okay, 2 into concrete cover from both ends. So hook length we have 2 into 14 dB, and bends we have 2D and 3D as well. Okay, for 90 degree and 135. So we have 3 and 2 over here. Okay, so let's put the values over here. A is equal to out to out distance we have find out over here 127.33 plus 2 into dia of this stirrup. Okay, this one and this one as well in order to find out this total. Okay, so A is equal to 139.33. Now B is equal to 300. This is basically we are taking as B is equal to 300 minus 2 into concrete cover from both ends. Okay, and B is equal to 220 mm. So let's put it in the formula. So cut length of 4 legged is A into 2 B into 2 plus 14 dB. Okay, I mean the hook length minus we need to do the bend directions for 90 degree and 135 degrees. So cut length is 814.66 mean 0.814 meter. Okay, so this is how we can find out cut length of 4 leg stirrup, and hope you understand what is 4 leg, what is 6 leg, what is 8 leg. Okay, and according to this process you can find out for 4 leg, for 6 leg, for 8 leg, for 12 leg. It could be any. Okay, main thing is to find out the distance. Okay, this distance between two bars. Okay, and if you can find out this distance, you can find out any of the leg. Okay, so hope you really understand this session. I'll see you in the next.